Welcome to The Explainer. Today, we're diving deep into the future of the smart cockpit. Think of this as a top-down technical briefing for automotive engineers, breaking down the core strategic shifts and the critical mandates you'll need to execute on as we charge towards 2026.
All right, let's just cut straight to the chase. The entire game for the smart cockpit is changing. We are moving way beyond the old model of just function stacking, just cramming more and more features onto the dashboard. The new mandate, the new mission, is to build an intelligent, deeply integrated space that is fundamentally AI native and fused with the user's entire digital life.
So we're going to structure our analysis in 5 parts, taking that top-down approach. We'll kick things off with a new paradigm, then we'll drill right down into the architectural dilemma, look at the silicon and software that's going to power it all, explore the revolution in the user interface, and wrap it all up with some concrete engineering mandates for 2026.
So here it is, the fundamental shift in thinking you need to embrace. The value of a smart cockpit isn't about the physical parts or how many features you can list on day one. Nope. Value is now all about its ability to be an AI-native, adaptable ecosystem that actually gets better over the life of the vehicle.
And you don't have to take my word for it. The market data screams this loud and clear. When you ask consumers what the single biggest benefit of a software-defined vehicle is, what do they say? The number one answer, with a whopping 37%, isn't better autonomous driving. It's a personalized experience. This is a direct order from your customers. Focus on building adaptable, user-centric systems.
Right, so this demand from the market for constant evolution, well, it creates the central architectural headache for every systems engineer today. You've got customers who expect their car to update like their phone, but you're working with hardware that's locked in for years. And this creates a fundamental tension. Do you integrate everything to crush costs, or do you strategically decouple to actually plan for the future?
And this leaves you with 2 distinct, almost totally opposite strategies. On one hand, you can push for extreme integration, cramming everything into a single cockpit domain controller or CDC to hammer down that bill of materials. Or, on the other hand, you can pull for flexibility with a decoupled companion device, which, let's be honest, is a direct admission that today's processor is going to be a fossil in 3 to 5 years.
Now, if you're going down that integration path, making a powerful CDC actually work is a massive physical layer challenge. This is where technologies from suppliers like Murata become absolutely mission critical. I mean, their resin mold packaging can shrink wireless modules by almost half while getting rid of heat better. And to keep those high-speed data buses from falling over, you need rock-solid timing, making these tiny, high-precision crystals completely non-negotiable.
And this is where you can see the sheer elegance of the decoupling strategy, laid out perfectly by Electrobit. The companion device does all the heavy lifting, running the latest OS, rendering that complex UI, and then it just encodes the whole thing as a standard H.264 video stream. It pipes that back to the car's main controller, which only needs to be a simple video decoder. Suddenly, hardware upgrades become as easy as plugging in a new, more powerful box. It's brilliant.
Okay, so whether your architecture is integrated or decoupled, it's all powered by the intelligence layer. So let's peel that back and look at the specific silicon and software that are going to make these advanced cockpits a reality.
When you look at the flagship SoCs coming for 2026, you can literally see the battle lines being drawn. It's not just about raw power anymore. Qualcomm is making a huge bet on power-efficient edge AI, cranking its NPU performance up by 12 times for on-device processing. Meanwhile, NVIDIA is just going for absolute central compute domination with Thor, targeting a mind-boggling 2,000 T-flops to consolidate the entire vehicle's compute onto a single chip.
Now, this whole idea of consolidating everything onto one chip is only possible because of a hypervisor. The best way to think of it is as a strict, totally unbribable traffic cop living on the silicon. It carves out protected little zones of memory and processing power, creating virtual machines. And this guarantees, absolutely guarantees, that a third-party music app crashing in the Android world can never, ever interfere with a critical warning light being handled by the safety-critical QNX system.
All right, with our architecture and our silicon sorted, we can finally talk about the real revolution for the driver, the interface itself. This is where generative AI stops being a buzzword and starts to completely redefine the human-machine interface.
And the leap forward we're talking about here is just immense. We're leaving behind those clunky, rigid, command-based assistants that only understand set temperature to 21 degrees. The next generation, they're true conversational partners. They get intent, they get nuance. So when you say, it feels a bit chilly in here,
The system knows exactly what you mean and what to do about it.
But, and this is a big but, for an AI to graduate from a simple chatbot to a fully integrated system agent, it needs a very specific technical foundation. Electrobit lays out these 5 essential enablers. You need the SDV platform, the standardized vehicle APIs, a theming engine, a flexible dashboard, and of course, the LLM voice engine. If you are missing any single piece of this puzzle, your AI is just a feature, it's not the core of the experience.
This brings us to a critical new discipline for your teams, prompt engineering. And I'm not talking about just chatting with an AI. This is about systematically, almost surgically, structuring your instructions to the LLM so its output is always a reliable, machine-readable command. You can see it right here. The goal is to turn a simple voice command into a perfectly formatted JSON object that your vehicle APIs can execute flawlessly every single time.
Okay, so what does all this mean for your work tomorrow? For the projects that are sitting on your desk right now? We've distilled this entire analysis down into 3 core engineering mandates that should guide every architectural decision you make between now and 2026.
Mandate number 1, design for upgradability, period. You have to stop trying to engineer a single monolithic SoC to last a decade. That is a losing battle against Moore's law, and you will lose every time. Instead, your core architecture must expect and embrace hardware evolution, and that means building in high-bandwidth interfaces from day one to support a future companion device.
Second, you absolutely must, I can't stress this enough, build an automated test pipeline for your AI. By its very nature, generative AI is non-deterministic. A model update from your supplier can change outputs in ways you never expected. That means your carefully engineered prompts have to be run through constant, automated regression testing to guarantee they don't break and cause some wild, unintended vehicle behavior.
And finally, mandate number 3, as you push for more and more integration in that CDC, you have to become obsessed with the physical layer. Don't let your software ambitions write checks that your hardware can't cache. High-speed signal integrity is everything. This demands a relentless focus on advanced components for precision timing and for thermal management, just to make sure the whole system is stable when it's under maximum load.
So we'll leave you with this. The architectural choices you are making today, whether you chase ultimate integration or you design for adaptation, they are going to define way more than just your next model year. They are going to define your brand's very ability to compete in a software-defined world. The question isn't if your car is smart anymore, it's if your architecture is wise.